So I'm going to show you a second method. Hopefully you like this one. So remember the quadratic function, the way I showed you how to graph the function, right? The most important point is the vertex. So this is what the quadratic function looks like in vertex form. And I want you to compare that to the absolute value function. Very similar, right? Your A is on the outside, right? Instead of P and Q, I'm gonna use H and K, and I think I mentioned this in class, right? So I don't know why the textbook here in Alberta uses P and Q for the vertex of the quadratic function. H and K is more consistent with the other functions, okay? The P and Q seems to be um, I don't know. It seems to only apply to a quadratic function, okay? But H and K is the more general term. So your H and K are your the coordinates of your vertex, okay? So we're gonna use this definition. So our function, right? The function that I need to graph is this one. Y is equals to what is it? Absolute value of x minus 3. Now I want you to compare this to this function, which is your absolute value function if you want in vertex form, right? So using this, you can convince yourself that your a value is equals to 1, right? Because this here is 1. You don't have to write the 1. The kind of like the coefficient of the absolute value, right? The number is 1. Um, and your h value, so minus h, so right, so just be careful, right? So what you see over here is minus h, right? So that means minus h is equals to minus 3, right? So that is the same as h is equals to 3, okay? So just be careful with the h, okay? Just like the p-value, it's kind of tricky because what you see up here, right? What you see up here is minus h. Okay, so this is minus h. Minus h is minus 3, so h has to be 3. Okay, so let's just write that down here. I think this should not be too confusing because you've already dealt with this. And your k value, right, because it's plus something that you don't see, it has to be 0. Okay, so k is 0. So now how does this work? Just like a quadratic function, okay, again, I'm just going to write this up here. So and then I'll just to make some room for myself. So because your a value is positive, right, your just like your parabola, this absolute value function will open upwards. Okay, so it will look like this. So just like your parabola look, when the a value was positive, it looked like that, and when it was negative, it looked like this. It's the same thing for the absolute value function. Okay, so it's gonna look like this. And h and k are kind of like your vertex. Okay, so if I were to graph this, what I would do is just this. Okay, very simple. um so my vertex is at 3, so this is, remember, this is kind of like your uh x, right? So your x coordinate is 3 and your y coordinate is 0, so 3 comma 0, this is your vertex. um your absolute value will open upwards, right? Because your a value is positive, but you need another point. Okay, so if you want, you can just find the y-intercept. So y-intercept will be given to you by, right, y-intercept is given when x is equals to 0. So I'm going to find the y-intercept of this function by just replacing x by 0. And when I do that, right, this is just the absolute value of minus 3, which is equals to 3. Okay, so this is the point. If you want, again, you can scale this however you want, right? 2, and then this is 3. Okay, and if you want to scale this, and this is 1, this is 2. Okay, and using symmetry, right? Because the y value is 3 at 0, then if you move 3 units to the right, it will also be 3. So this has to be 6, right? So this is the point 6. And there you go. Okay, and then you can just extend it this way. Okay, and that's how you graph your absolute value function using the second method, okay, so where you kind of like treat it like essentially like a quadratic function. Okay, so start with the vertex, find another point. The easiest point that you can find is your y-intercept, and there you go, right? And then you can use symmetry to get the other point. And then this is basically what the quadratic function or the absolute value function will look like. Okay, so again, treat it like a quadratic function, and you can just graph this kind of like in one shot, right? You don't have to treat this piece and that piece separately. You do everything at once. I think this is a better way of doing it, but this is not how your textbook shows you how to do. Okay, so this is something that um, I learned in Montreal, and I think honestly it's way easier. Okay, but again, you have a choice. You can use method one if that made more sense to you, but I think method two, because you've done quadratic function, should be very familiar. Okay, now just a thing that I'm going to point out, right? So this only works when your function is written in this form, okay? In other words, your coefficient of x has to be 1, okay? If there is a coefficient in the front, you need to get rid of that, okay? So, which is what we're going to do in the second example. Okay, so in this case, I'm going to graph this using method 2, but the problem that I have is my coefficient is not 1. So what I'm going to do is I'm going to factor the half. So if I factor the half, then this becomes x. This has to be minus 6, okay? Some of you might find this a little weird, but think about it this way. If I distribute this again, right? Half times x is half x, so I get that. Half times minus 6 will give me minus 3, right? Because multiplying by half is kind of like dividing by 2, okay? So when you factor the half, you have to kind of like double this value, okay? So just be careful when you're factoring fractions. It can be a little confusing, but whenever you factor, always double check at the end by redistributing and just to see if you get the same thing back, okay? And in my case, I do. Now, what I'm gonna do is I'm gonna use one of the properties that I showed you in I think my first video or something. Okay, so when you have absolute value of A times absolute value of B, then you can kind of like apply the absolute values to each of them separately. Okay, so so I have a half times, right? Brackets means times x minus 6. So this is the same as absolute value of half times absolute value of x minus 6. Okay, but absolute value of half, because it's already positive, is just half and then x minus 6. Okay, so now this looks again, you have to put this in this form, right? Y is equals to a absolute value of x minus h plus k. Now this looks in that form. Why? Because the coefficient of my x is 1. Okay, the coefficient has to be 1. And now you can kind of like, convince yourself that your a value is equals to 1, a half, I mean, right? So this is your a value, right? Whatever is on the left hand side of your absolute value, basically, right? If you compare it to this function, so a is half, which means my half is positive, right? So that means my absolute value will open upwards. My h value is 6, right? Remember, you have to flip the sign, and my k value is equal to 0. Okay, and why don't we find the y-intercept? So y-intercept is given to you when x is equal to 0, right? So y is equals to a half 0 minus 6. I'm just replacing this x by 0. And then if you work this out, it becomes half absolute value of minus 6, which is, the same as half times 6, which gives you 3, basically. Okay, so this just becomes 3. Okay, and maybe I'm just gonna add an extra page. Sorry, this is getting a little bit longer than I had expected, but I don't want to do this too quickly because I don't want to confuse you guys. Okay, so why don't we graph this very quickly? So this is my x, this is my y, and right. So my vertex is 6, 0. So again, you can scale this however you want, and my y-intercept is 3. So if you want 1, 2, 3, right? So if this is 1, this is 3, so this is my y-intercept, and I'm just going to scale this by 2. So this would be 2 and then 4 and then 6. Okay, so this is the coordinate of my vertex, right? It's 6 comma 0. So at 6, my absolute value, but this is my vertex, and then I'm just gonna, because it's, your a value is positive, it's a half, it's opening upwards, I just need to connect the two dots this way. And then using symmetry, you can find the other dot. It will be somewhere over here. If this is the point 6 comma 0, then this is the point, right? Using your y-intercept, it's the point 0 comma 3. And using symmetry, right, this distance is 6. So if you add 6 to it, this has to be the point 12 comma 3. Okay, and there you go. Okay, that's what your absolute value function kind of looks like. So one more, and then I'll let you do the homework questions. Or actually, there's actually two more. Okay, so this one, let's just do this very quickly. Right, again, the problem is the coefficient of my x is not 1, so I need to factor this. So I'm going to factor the -2. So y, I'm going to factor the -2. This becomes x, and this will just be I mean, you could use a calculator, but let's just say minus 1.5, right? Because -2 times -1.5 will give you 3. Okay, it's kind of like all you have to do is just divide this by 2, -2 actually, which is why this is negative. Okay, and when you multiply two negative numbers, you're going to get a positive number. Okay, so and then there's a -2 on the outside. Now this question cannot be done by definition because you have this extra -2. So if you do this by definition, it's going to be very tricky. But if you do this using the technique that I've shown you, it's not going to be difficult. Okay, so in this case, I'm just going to distribute my absolute value, right? So it's going to be absolute value of, again, using the fact that, absolute value of A times B is just equals to absolute value of A times absolute value of B. Okay, so I'm distributing my absolute value, and then -2. So, right, when you take the absolute value of a negative number, it just becomes a positive number. So this is just 2x minus 1.5 and -2. And there you go, right? So my a value, I'm just going to put this here just to make some room, is equals to 2. So that means my absolute value function will open upwards. Okay. And my h value is 1.5. My k value is -2. Okay. And I'm using, this is my h, that's my k. Okay. And there you go, right? This is everything that you need. So very simple. Maybe, right, finding the y-intercept would be useful. So why don't we do that calculation somewhere down here? So y-intercept will be given to you when you replace your x value by 0. So y will equals to 2 times 0 minus 1.5 minus 2. So this will just become 2 times 1.5 minus 2, which is just 3 minus 2, which is just 1. Okay. So at 1.5, so let's scale this by 1. So I'm here, this is 1, this is 2, and I'm going to scale my y values by 1 as well. Okay, so this is 1, so this has to be 2, this is 3, this is -1, and this is -2. So at 1.5, right, at 1.5, my y value is -2, so this is your vertex, 1.5 comma -2. Y-intercept is 1. So at 0, my function is at 1. Right? In other words, at 3, right, because this is 1.5. So 1.5 plus 1.5, this is 3. At 3, my function will also be at 1, right? Using symmetry. And then just connect the two dots. Okay, so there you go. And there you go. Okay. And if you want, I can label the points for you. So at 0, I'm at 1. At 3, I'm also at 1. Okay. So very similar to the quadratic function, right? Not too difficult to graph if you use the second method. And again, this question will be very tricky if you use the definition. Okay, and if you would like to know how to graph this using the definition, please join me during my office hours. But please do not use method one to graph this function. It's going to be very challenging for you. Graphically show that this equation has no solutions. Okay, so let's just graph this. Again, the problem here is that, the coefficient of my x is not 1, so I'm going to have to, so this would be my first function. So graphically, when they're asking you to show that graphically there's no solution, graph this function and graph this function separately and show that there's no point of intersection. Okay, so let's work with the function in red. So I have 3x plus 3, right? I'm going to factor the 3. So that becomes x plus 1. And then, using the definition of absolute value here, I'm just going to use the shortcut. This just becomes x plus 1, okay? Right, so you just apply the absolute value to this and that separately, but absolute value of 3 is just 3 because it's already positive. So you would have to graph this function, not too difficult, right? And graph the other function, which is y is equals to 2x minus 5. So this is just a linear function. If you want, this is your slope, that's your y-intercept. Should not be too difficult to graph that one as well. So, right, so let's just quickly graph. So I'm going to use purple for my Cartesian plane. So my first function, right, if you want, my a value is 3, so that means my absolute value function will open upwards. My p value, or sorry, h is just be careful. It's the opposite of what you see, right? So h is actually -1, and my k is equals to 0. Let's put the k over here, okay? So just be careful. I know the h and k would confuse some of you, right? Because you've been using p and q, but honestly, it's because that's how the textbook presented it, so I decided to be consistent. But this h and k, you're going to see this a lot in 30-1. Okay, so get used to h and k. I don't know why they show you p and q for the quadratic function. It's just it just messes with your head. Okay, it just makes it confusing. Anyway, so I'm going to start with actually, so it's h is -1, right? It's the opposite of what you see, right? So this is +1, then h will be -1. So this is my vertex. Okay, so let's just, if you want, increase everything by 1. In which case, I'm just going to move this a little bit up. No, maybe not. Something like this, okay? Because the -5 is what's kind of like bothering me. So x, y. So let's start off with the function in red. So at -1, I am at 0. My a value is positive, right? So this is what my function will look like. Okay, and you can find the y-intercept if you want. It's just 3. Okay, so if you plug in x is equals to 0, you're gonna get 3. Now for the function in blue, right? I'm starting at hold on. If you want, you can draw this to scale, but you don't have to. So if this is 3, then -5 will be a little bit, further down. My slope is 2, it's positive, so my function is supposed to increase. But you see, this function, right, if you were to use the definition for this absolute value or whatnot, you will see that, if I were to write this as a piecewise function, right, then this would, let's just do it over here. This would equals to y is equals to, or let's just do it down here actually. So, right, if I were to write this as in a piecewise notation, so y will just equals to 3x plus 3, right? If 3x plus 3 is greater than or equals to 0, right? So if you can think of this as your slope. So because the function in red has a slope of 3, again, I'm just going to erase this to make some room. The function in red is supposed to increase more rapidly than the function in blue because the function in blue has a slope of 2, okay? And if you do this to scale, right, if you kind of like scale everything with 1, 2, and 3, you will see that this function in blue will increase less rapidly than the function in red, okay? Rapidly, I mean, so see this function is increasing at this rate. So this function will, this would be parallel, right? If they're increasing at the same rate. But because the slope is 2, it's actually going to be increasing at a slower rate. Oops. So something like this. And that's why there's not going to be any intersection, okay? So graphically, you could see that there's no solution. There's no solution because there is no point of intersection, okay? These two graphs are not touching each other. There would be a point of intersection if this value was actually greater than 3. If this was 4, then this function would increase more rapidly and it would have touched the function at red at some point. But because this value is 2, it's actually increasing less rapidly. And again, you don't need to worry about that. If you do this by scale, right? If you scale everything, by 1, if you want your x values by 1 and your y values by 1, then you will see that that this function does increase slowly, okay? So because I'm not scaling it, I'm just kind of like telling you what you will get if you do this by scale, okay? So anyway, so this is how you show that there's not going to be a solution, okay? Just graph the function on the left and the function on the right and show that there's no point of intersection, okay? So sorry for the long video, but the next one is not going to be, I'm hoping it's not going to be that long, and I'm only going to post 2 this week. So I want you to do the graphing questions on page 376, question 6, and I think it has many parts like A, B, C. Do all of them, and also do question 23 on page 391, which is very similar to this question over here, where you kind of have to graphically show that there's not going to be a solution, okay? And how do you do that? Again, just graph the two functions separately, right, on the same Cartesian plane, and show that there's no intersection, okay? The two functions are not intersecting anywhere, and because they're not intersecting, there's not going to be a solution, okay? Because remember, the solution is your point of intersection, and in this case, there's not going to be any point of intersection, okay? Because these two lines are drifting further and further away from each other, okay? So they're never going to touch. So yeah, so just do that. Sorry for the long video. I hope method 2 kind of made sense. If not, please let me know. Send me an email, or show up during my office hours, and then I can maybe give you more instructions on how to graph an absolute value function, okay? Okay, guys, have a nice day. Thank you so much for watching my video. Unfortunately, it was long, so I apologize for that, okay? Take care. Bye.